Alright, so here we're looking at Formula 9, and before anybody says, what about Formula 8? We don't have to prove Formula 8 in the Leaving Cert, which is fantastic. So we're looking to prove tan A plus B is equal to tan A plus tan B, 1 minus tan A tan B, all over 1 minus tan A tan B. This is the most common one that has come up in the exam, so it's really worth looking over. And I actually think it's the easiest one. It's the one that you should probably focus on the most, but it is one of the very easier ones once you learn off these 3 bullet points and that you've got good use of fractions as well. So we're starting off with tan A is equal to sine A over cos A. But remember, A could be anything. It could be a bracket. So it could be tan bracket is equal to sine bracket over cos bracket. Then we move on and use page 14 of the log tables. Okay. And then we aim for 1 on the bottom left hand corner, and that's why I have 1 highlighted there, which might seem a little strange, but it'll become clear to you in a second. Okay, so looking at the proof then, so we're saying tan A plus B would be defined as sine A plus B over cos A plus B. Because remember, tan is defined as sine over cos, and then the angle just stays the same. When I said use page 14, I mean find that rule on page 14 and replace it with that. And then find that rule on page 14 and replace it with that. And here's the one tricky bit that you need to be good at fractions for, or have a good understanding of fractions. How do I want to make this 1. Remember, look back at the start. We want this to be 1. Well, how could I make it 1? Well, I could divide it by itself. But I can't just divide that section there. This would have to be over B as well. I can't just divide that section by 1. I'd have to do it to absolutely everything. Now, instead of dividing by 1, I think of it as dividing by itself, I think it as multiplying by 1 over itself. So if we're looking at here, if I wanted to make this number 2 the number 1, I'd multiply it by half. 3 is the same as, or 3 by a third is the same as 1, or x by 1 over x is equal to 1. So I'm going to multiply this section by 1 over cos A cos B. But I can't just do it to just that section. So how could we make this 1? Well, the only thing I can actually multiply by is the number 1 without fundamentally changing the number at all. But 1 is the most versatile number. It can be written in any way. 1 can be written as anything over anything. Okay? So remember, I want to multiply this by this, but I can't just do it to one section. I can only multiply by the number 1, and the number 1 can be written as 1 over cos A cos B over 1 over cos A cos B. If that makes sense, hopefully it does. So what I'm saying is this number here is effectively the number 1, and I'm not changing anything. So this next blue line is possibly not required. It's not required, but I think it's a good explanation. Remember, this line here is a fraction, it's over 1. This here is a fraction, it's over 1 as well. Everything could be written as over 1. And then, how do we multiply fractions together? Well, we multiply fractions by going top by top, bottom by bottom. So it is this by this, this by this, this by this, this by this. Then lots of cancelling occurs. So I'll remove all of that because it'll look a little nicer. Lots of cancelling occurs. Cos B divided by cos B be 1. Cos A divided by cos A is 1. Cos A divided by cos A is 1. Cos B divided by cos B is 1. And finally, how does it all change to tan? Well, remember, sine of A over cos of A is tan A. Sine of B over cos of B is tan B. All this section became 1. And sine A over cos A would be tan A. Sine B over cos B would be tan B. And that is the question proved. Okay, now it really is worthwhile putting a bit of effort into that, because it does come up as a Leaving Cert question fairly regularly. Definitely worth putting effort into. Hopefully you found this useful.